Hello and welcome all of you to Easy Electrical. So in today's class we will be starting our last part, that is the our last subject. Basically in this we will be dealing with the maintenance part, and in that case we also deal in this case also that utilization and traction part as well. So for the first two lectures I have decided to take up illumination as the subject. Okay, so today is your 7th of October 2021. Now all of you by the time must be knowing that we are having running one course, that is SSC JE, and this also includes our WBPSC course and similar to our your what you can say railway part. Okay, so separate batches are basically launched for all the courses, and the modules are remains the same, most more or less. Now here you can see you can get a concept based classes for technical, for non-technical. You could get the test series, the practice papers, as well as the recordings of all the classes. Okay, and the notes are always there. So other than this we have tried to add two more points. That is, one thing is a, we call it as a exam specific notes. Exam specific notes, these are basically designed for different exams. For say SSCJ, there is a special exam specific note. For WPPSC there is special. For railway there is separate notes are there. And one more thing that we are adding in coming days, that is the labs, that is the practical labs. Okay, so for electrical machines, for power systems, and some of the classes of the measurements will be introducing labs as well in our coaching program. Now coming to today's topic, that is the maintenance testings and UTHD. So first of all we will be take up our illumination portion. So for illumination portion, a small brief understanding or brief introduction I'd like to give. Here you can see a bulb I have shown. Okay, so the bulb is emanating some amount of light energy, and that light energy is, we call it basically the luminous flux. Okay, now the particular direction, in a particular direction, what is the amount of the flux that is getting emanated is called as the luminous intensity. And per unit area, whatever the light is coming, we call it as illuminance. And one more part that is very much important, that is called as the luminance, that is how much amount of light is getting reflected from the surface. So these 4 points and these 4 figures are the fundamentals of the lighting systems. Okay, so here you find the luminous flux, that is the amount of light that is getting emanated. Luminous intensity, the amount of light that is coming out and falling on a surface. The amount of light that is falling on the surface per unit area is basically your luminance. And the amount of light that is accepted by the eyes, that is from after reflection, is called as the luminance or candela per meter square. Now we will start with our first question. That is, in the first question you see that radiant energy is the ratio of. Okay, so there are some of the terms you might be first of all introduced for today itself only. So you just go through whatever I am saying, and if you want to follow any book, there is a book called Sir H Partap. Okay, so you can follow that book. Okay, for the illumination part, that is the best book written, and you can follow that. So from there you can get more of the theories. Now the radiant energy is the ratio of, basically it is the ratio of energy radiated out in the form of light by total energy radiated by the hot body. Energy radiated in the form of heat to the total energy radiated by the hot body, or the energy radiated out of in the form of light and heat. Basically radiant energy means that whenever we heat a body, suppose a body is there, we are heating it. Okay, so by heating it, first of all its temperature increases and the color of the body changes. Now after a certain time, what happens is, after a certain critical temperature, the body starts to emit light. Okay, so basically radiant energy means the ratio of the energy radiated in the form of light divided by the total energy radiated by the hot body. That is the basic ratio. Now the next question is, what is the unit of Armstrong? Armstrong unit. 1 Armstrong is how much it is? 1 Armstrong is 10 to the power minus 8 centimeter. Okay, 10 to the power minus 8 centimeter, or sometimes in the question they may give like this, 10 to the power minus 10 meters also they may give. Both of them are same, you all know. The next question is, the stereodian is the unit of. Basically, stereodian is the unit of the solid angle. In the plane angle, we basically use radian as the unit, and for plane solid angle, we basically use stereodian. Now, to get the idea about what is a solid angle, uh, suppose you take a cone. Okay, you take a cone like this. Okay, you take a cone like this, and by the cone, if you cut a cross section like this, if you just cut like this through any point, then the angle, the circular angle that is made by this point with the total surface, with the total circular area, is basically called as your solid angle. ওকে, আমি যদি একটা বাংলায় বলি, একটা বরের টোপর যদি তুমি দেখো, বরের টোপর মাঝখান দিয়ে তুমি যদি কেটে দাও, তাহলে what you will find is the solid angle. If you look from the top, the angle that is formed is called as the solid angle. Now coming to the next point, that is, what is the unit of candela? Luminous intensity. Candela is the unit of luminous intensity. Okay, so you must keep in mind that thing. And solid angle, we have find that stereodian. Okay, and luminous flux is lumen. What is the amount of light that is coming out? The lumen amount of lumen is basically the unit of luminous flux. Now coming to the next question, what is the 1 lumen is equals to? In SSC examination, sometimes this numerical value type questions are asked, but what I will recommend to you is that just keep in mind these things, because these are very important parts, and you will face certain problems, you will face certain questions where you need to memorize the data. Here this is the data, 0.0016. Now coming to next question, the ratio of the total flux transmitted to the total flux incident. Okay, so whenever it is saying that it is transmitted by incident, that means it is called as a transmittance. Okay, suppose if it is said that the total flux reflected by the total flux incident, if it is said that this was reflected, then it is called as the your coefficient of reflection. If it was said reflected ray, in that case you will say there is a coefficient of reflection. Coefficient of reflection is basically what? Total flux reflected divided by the total incident light. Now the next question, what is the unit of luminance? Luminance is whatever light we are accepting. The unit is candela per meter square, where candela is the luminous intensity. Okay, in a particular direction, what amount of the light is going, there is your intensity, and intensity per unit area is basically your luminance. Now illumination E is proportional to luminous intensity I square, 1 by I square. None of this, basically you all know, if you study the uh, square law, where you will find this I, illumination E is basically proportional to your I. Okay, now the total flux output in lumens divided by 4 pi, total flux output divided by 4 pi is, what do we call it? Mean spherical candle power, luminous efficiency, uh, means hemispherical candle power, or what? This is basically your mean spherical candle power. Mean hemispherical candle power is basically the total flux that is coming out, output in hemisphere. Okay, divided by 2 pi, just divide it by 2 pi. In that case we will get the hemispherical. Now luminous efficiency, we all know, lumen per watt. That means what amount of the light is coming out with respect to what amount of input power we are giving. Now coming to the next question, here I have taken a small problem. Here you can see, given there is a light having your 1200 lumen in all direction and suspended at a height of 8 meter above the working plane. calculate the illumination at the point on the working plane 6 meter away from the feet of the lamp. Suppose suppose in this position I have put a lamp, and it is saying that it is above 8 meters, so the height is 8 meters, and what they are asking is they are trying to find out this value at 6 meters away. This horizontal displacement they have given is 6 meters. So from this you can get what is the value of this. Suppose this is A, this is B, this is C. So what you can get is the distance AC will be your root over of 8 square plus 6 square. From this you can get this is basically your 10. And what is the angle between the two? Suppose this is theta, so what will be your cos theta? What will be your cos theta? Cos theta will be basically your 8 divided by 10. 8 is your this side, and 10 is your this side. Now we all know that illumination is basically we calculate E, so E equals to I divided by r square into cos of theta. Now you basically see this AC is your r value. This AC is your r value. Now if we put the value here, and what is I? I is basically your whatever the light is coming out, that is 1200 lumen divided by 4 pi. So if you just do the calculations, you will get 1200 divided by 4 pi into r. Here it is 10, that means 10 square, and cos theta we have obtained as 8 by 10. Now if you just calculate the two, then you will get this 2 will cut, this will be 2, so here you will get 24 divided by 10 pi. So roughly the value will come out to be 0.76. You will just calculate and you will get the data 0.76, and this is the process. If you calculate this data, you will get the 0.764 value. This is coming out to be 0.764, something like that it will come. Okay, so thank you for staying up to this point. This is the last question for today. If you have any doubts, you all know that you can call us at you can send us a message at WhatsApp message at this number. It is already mentioned here. You can mail us at this mail ID is also given. And if you want to join our SSCJ doubt discussion group, you can join this WhatsApp group. Okay, the link is given. Just type on the URL and press, and you will join the link. So thank you everyone for staying up to this point. We'll see you in the next class. Thank you.